Okay, so today we'll be discussing the netlists regarding an XOR gate. Uh, as described in the previous video, the we have a netlist we create so that we identify it's a hard descriptive language to describe the circuit on a transistor level. So in this example, we created an XOR gate. Gate is created how? We have four PMOS gates. Um, for the first XOR, this is two input XOR gate. So the first input we will have the first input, and the second input has to be inverted. So and for the third and the fourth PMOS, we will have the third PMOS as this one. It's inverted from the first one, and then the PMOS the second. So it's opposite in interval as you may look for a video to try to understand how to create an XOR using transistors. And in this, then we have the NMOS. We have the NMOS for the input 0 and 1, and then we have the inverted from 0 and 1. So we have the inputs, but we still have to invert the input 0 or input 1 in order to use it here. So the inverted ion the gate will take an inverted version of the input 0, and here from the inverted is same for input 1. You have to invert the input 1 to go here, and then same for these two. So in order to do this, we created an inverter for input 0 and input 1. So we have here the inverter to input 0 and input 1. So and we have this for the inverted one. Inverted 0 and 1, this would be called so the output which we will use here, this is node 6. And here the input one in the inverted version is the node 7. So in order to do this, we have to write the 4 PMOS and the 4 MOS, and also add the 2 PMOS, the 4 and 5, and we have to add also into our consideration the NMOS. So the NMOS we also is same thing. So we have to have we have 6 PMOS and 6 MOS in order to obtain the XOR gate. So as I just since most of the time when you're creating a netlist, you have to do two things. You have to create for gates or for what you're using, and you have to write the Verilog code in order to explain, like next to the RTL or the Verilog for the gates, you have to write another Verilog for this to explain what's spice netlist. So and most of the time you don't most of the Verilog codes you usually use what? You don't use one gate. You use different gates. So this is a subcircuit. As I explained before in the previous video, we did a subcircuit for the XOR, for the NAND. Now we're going to do the subcircuit for the XOR. So as described before, in order to write, so we have to write subcircuit. So we're going to call this XOR. Or call it what you want to name your you have to name, of course, your Verilog. Verilog code has to have the same name as the subcircuit name. Okay, so we said we have Um, so we will leave the we can, so let's remove the 3 here, and let's, so I have explained I have 6 PMOS. So we write for the first PMOS, so I named it as XP0. And so XP, how do we do the PMOS or the MMOS? We have drain, gate, source. So for the XPMOS, what's our drain? Our drain is node 0. So N0. Then we have gate. So what's our gate? It's input 0. So we write input 0. And what is our source? Our source is VDD. And then we have our second. So this is XP1. And we have the VDD. So it's this is the PMOS has to use VDD to be to in order to make the circuit work. We need a VDD. So with PMOS, we normally use, we have VDD here. So we have the VDD, and then there is VR PMOS. This is in the circuit. It depends on the architecture of the FPGA. But in open FPGA, for example, this is called VPR PMOS. And then we have the length. Let's go for XP1. So XP1 is what? XP1, we said drain, gate, source. So drain is what? Node 3. Then we have node 3 and input 1 inverted. What's input 1 inverted is here. So it's node 7. 7. Then we have node 0. Node 0. Then we have the VDD as this is VMOS. Then we have to write, we're going to write our next VMOS. So I named it XP2. As I said before, you can name it whatever name you want. XP2. So we have XP2. What's our drain? Our drain is node 1. So node 1 and 0. No, this is N1. N1. Then we need the input 0. In input 0, it has node 6. So node 6. And then we have VDD. And we have another VDD. So it's a PMOS. VPR PMOS. Um, then L equal PL. Okay. Then we have our next PMOS, which is XP3. XP3. Sorry about that. Okay, so XP3. So we have, as I said, XP3. So XP3 is what? It's drain, gate, source. So our drain is N3. Then we have input 1, so just input 1. Then we have node 1. Um, then so now then we need the VDD, VPR, PMOS. L equal PL. PMOS. So now we have we created the 4 PMOS for the XOR. We have to also add the next two. So the next two for the inverting. So we have XP4. So XP4 we have what? Here we have input 0, which is node 6. So we have node 6. Node 6. Then we have input 0. Then we have VDD. Node 6. Input 0. We have VDD. This is powered by VDD. And we have VPR. PMOS. L equal PL. So we're going to create our last PMOS. Our last PMOS is N7 input 1 and then VDD. Then we have VDD, VPR, PMOS. L equal PL. Okay. Then we need to have to write for NMOS. So our NMOS is what? Drain, source, gate. So our drain is here. So our drain is node 3. Then input 0, then N4. Then we have this powered by ground. So we have ground, then VPR NMOS length. This is NL, and then we have our next. So we're writing our X. Oh, we didn't write the XN1. So XN1 is N4, N4. Then input 1, then ground. So this is ground, and here ground. Okay. And then so we have N4, and 4, input 1, ground. So then we have X n. So we have Xn, this is Xn2. So our Xn2 is node 3. Then gate the input 0. So our input 0, this is input 0 inverted. So input 0 inverted, this is N6. So N3, N6, N6, N3, N6, N5. Then as ground, the PR and MOS L equal PL NL. Then we have our next MOS, which is the last MOS for the XOR, and then we have to write the two MOS for the inverted input 0 and input 1. So Xn3 is N5, then input 1 inverted is N7, then we have as ground, then we have as ground, then VER NMOS L equal NL. And 4 for the first inverted input 0. So we have it as N6, drain source, so input 0, and input 0, and then we have ground as ground. We have as ground, then VER N plus L equal NL. And then we have our last NMOS. Our last NMOS is our drain is N7, node 7, then input 1, then we have as ground, then as ground, C, R, NMOS, L equal NL. We can then add our size, the width, and then we have end of subcircuit, so which is written as .eon. So that's it for this video regarding how to create a netlist for XOR, which is a little bit more complicated than the normal AND gate, since we have to create another PMOS and NMOS, we have to think out of the box to create the PMOS and the inverted input and 0 and 1. So same thing, if you want to create a NOR gate, just have to change the input 0 and input 1, the inverted, which is the inverted, but same idea and same way you would use to write any subcircuit. All this regarding gates. So that's it for this video. In the next video, we'll explain more netlist for another circuit. Thank you so much.